Okay, if the matrix A, B, C, D reduces to 1, 0, 0, 0, what can we say about A, B, C, and D? Now, I'm just giving you an idea of how to approach this. I've got a fair amount of detail in here, but you really need to work this out yourself. Also, this is probably more relevant to the Math 285 course than to the Math 177 course. It'd be great if you understand it well enough to do this, whichever course you're in, but you're unlikely to see a question of this nature on a test in 177, not at all unlikely in 285, although I don't guarantee there'll be one. So, what can we say? Well, let's just reduce this matrix. Now, I haven't written all assumptions down, but let's assume that A isn't 0. If A is 0, then C can't be 0, because if A is 0, the only way we're going to get a 1 here is to flip these two lines and divide the first row by C. But let's assume that A isn't 0. C might be, it might not be, it doesn't have to be. Okay, so what we do is we take this row to reduce the matrix, and we're going to divide this row or multiply it by 1 over A. So that A, B, C, D is going to become 1B divided by A. And then we still have the CD. Okay, so that gets us the 1 here. Now to get the 0 here, what do we have to do? We have to subtract C times the first row. And if we do that, of course, we're going to get 0 here. That's why we subtracted C times the first row. And also D minus C times B over A. D minus C times B over A. Okay? Now, that matrix is not of this form yet, but it will be if, well, in the first place, if B is 0, then this term is 0. And the only way this term is 0 is if B is 0. A is in the denominator. There's no way we can divide by something to make this 0, so we're stuck with B having to be 0. Assuming that A is 0, B has to be 0. But then since B is 0, and well, this second row, second column entry, D minus C times B over A. Well, we know now that B is 0, so that C times B over A is 0. And we know that this entry has to be 0, and the only way that can now happen is if D is 0. So we've concluded that B and D both have to be 0. Now that's if we assume that A is not 0. But if A was 0, C couldn't be, so we'd flip these, and we'd still come up with the same conclusion that B and D both have to be 0. So, ultimately, one of these two, A and C, has to be something besides 0. The other could be 0, but it wouldn't have to be. But that B and D both have to be 0. So we can draw those conclusions. And drawing those conclusions, we simply reduce this matrix and match up the reduced matrix with the form that we say it has to have. It takes a little thinking to do that. This is not something that's generally familiar to people in their freshman year of college. And this course is, of course, aimed at freshmen who have had some calculus, okay? So it's aimed at freshmen that have pretty good background, but it's still something you're probably not been asked to do very often. So think that through.